I will refer you, in this problem we're going to go from liters to grams to mass. I'll refer you to the other problem that I also have posted going from grams to liters. It's the same process. I'm not going to go the full detail here. I'm just going to show you the steps. We have our 5.00 liters of chlorine gas. Is it at STP? No, it's not. It's at 105 and 20 degrees Celsius. And we're going to grams of sodium. So in this case, I must do combined gas law first. So to find V2, I'm going to take V1, P1 over T1, T2, P2. This is my P1, this is my T1, and STP is equal to my P2 and my T2. Okay? So that's going to give us a number. Let's say that gives us 4.83. If I'm not mistaken, that's how many it gives us. 4.83 liters of Cl2. That is when I'm going to then plug that number in. So let's say that this equals V2 equals 4.83 liters. That number is what I put into my skeleton, not this initial one. I do the new volume at STP because the first thing I want to do, bringing the units down, is to go 22.4 liters of Cl2 in 1 mole of Cl2. And that's, of course, using the tool molar volume. That's locked. You cannot use molar volume unless this volume is at STP. Use my coefficients of my equation. But Mr. S, there is no equation. Well, I've got sodium reacting with chlorine, so you need to write an equation. Sodium plus chlorine produces what? Sodium chloride. Chlorine is diatomic, so therefore there must be 2 here to balance those chlorines, which means there must be a 2 there to balance those sodiums. So I'm going to sodium. Moles of chlorine come down, and moles of Na go up. What are my numbers? Well, I look at my coefficients, and I've got a 1 to 2 ratio. Next, I want moles of Na to go here, and grams of Na there, because that's what I want to end up with, grams. What do I do to find the grams? I look at my periodic table, and I see that grams is 22.990 in 1 mole, because this being molar mass is always 1. This was my coefficients tool, and so I pop it in my calculator. 4.83 times 2 times 22.990. I divide that number by 22.4, and I get 9.91443. I look back to see what's my significant digits. I've got 3 here, I've got 3 there, and I've got 3 there. So therefore, I'm going to use 3. 1, 2, 3, draw my line, ignore these. 4 tells the 1 to stay. So 9.91 grams of Na.